So in this video, I'm going to show you how you can evaluate the limit of a function that is a fraction containing radicals, so like the one that I'm showing you here. You may start by using our direct substitution method and plug it in for -2. However, you get something known as the indeterminate form when you have 0 over 0. So all that means is that there has to be some sort of algebraic manipulation that you must do to your expression before you can evaluate the limit. The strategy that I'm going to use today is known as the conjugate, and that's just where you change the sign of the middle two terms. So for example, 5x minus 7 versus 5x plus 7, those would be conjugates of each other. Now I'm going to be strategic and use the conjugate of the numerator. So that's going to be the square root of x plus 6 plus 2. So I multiply both the top and bottom of my fraction. And then I'm going to go ahead and multiply through in the numerator. So the square root of x plus 6 times the square root of x plus 6 is just going to be x plus 6. Next, I'm going to go ahead and take the square root of x plus 6 and multiply it by 2. So I get plus 2 times the square root of x plus 6. Start with -2, multiply it by the square root of x plus 6. And then -2 times +2 is going to be -4. All over. Now in the denominator, I'm not going to multiply through. I'm going to leave these as the product of these two terms, x plus 2 times the square root of x plus 6 plus 2. And we'll kind of see why here in a second. So I left I used different colors here because the strategy that we're using, the conjugate, these middle terms are always going to cancel out because of this plus or this minus and this plus sign here. And so it just saves some space on my paper if I don't actually include that middle part. So in future videos or in class or you see answer keys, I'm not going to include that part because it's always going to cancel out. So the limit as x approaches -2, in the numerator I have this x plus 6 and -4, so the result's going to be x plus 2. And you can kind of see now why I did not multiply through in the denominator, because those x plus 2's are going to divide out. So I now have something that looks like this. The limit as x approaches -2 of 1 all over the square root of x plus 6 plus 2. So now when I use my direct substitution, the result is going to be 1 over the square root of -2 plus 6 plus 2. -2 plus 6 is the square root of 4, and the square root of 4 is 2. So 2 plus 2 is 4. My final answer is going to be 1/4.